Hi, everybody. My name is Bill Troutman, and I am your math instructor. Okay, so today I'm going to cover sections 4.1 and 4.2. Um, and I'm in the actual workbook. So if you go to, I think, Module 1, I put the workbook in there, and you can take a look at it. This workbook is what the face to face classes use in class as notes and practice problems. So let's go straight to 4.1. Okay, so it just says identify the pattern. And by the way, this week you have a quiz in Canvas, and it's very similar to these problems. Identify the pattern. If you look at this 1, 3, 5, 7, 9, it just looks like it's every odd number in a row. After a 9 comes 11. 11 is odd. And after 11 comes 13. So that's what I would put. Let's look at the next one, example 2. 1, 3, 9, 27, 81. It's not blatantly obvious here, but this is what you can do. You can try to, between 1 and 3 is 2. 3 and 9 is 7. 9 and 27 is 18. 27 and 81 is like 54. I don't see any kind of pattern there. Let me clear this off. Is there a clear? Yes. So I don't see any pattern there. However, I do notice something. 3 is 3 to the 1 power. 9 is 3 to the 2 power. 3 times 3 is 9. 27 is 3 to the 3rd power. 3 times 3 is 9, times 3 is 27. 81 is 3 to the 4th power. 243 is 3 to the 5th power. You can try that on your calculator. 3 to the 5th power, you get 243. So how do I get 1? If I have 3 to the 1 power, here, if I put 3 to the 0 power on my calculator, I actually get 1. So it's 3 to 0, 3 to 1, 3 to 2, 3 to 3, 3 to 4, 3 to 5. So on my calculator, the next number should be 3 to the 6th power. 3 raised to the 6th power. So that's all I just did, typed in 3 to the 6th power, hit enter, and it gets 729. And then I'm going to try 3 raised to the 7th power, and I get 2187. So that was a little different. This next one's kind of weird too. 4, 9, 16, 25, 36. Do you see the squares? This is 1 squared. This is 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared, 5 times 5 is 25. 6 squared, 7 squared, 7 times 7 is 49. So 8 squared, 8 times 8 is 64. And 9 squared, 9 times 9 is 81. Alrighty. Let's see if I can bring this up. Am I able to bring that up? Yes, I am. Okay, number 4 might be a little bit harder to figure out. 1 plus 5 is 6. 6 minus 2. 4 minus 1. 3 plus 4. 7. I don't know. Yeah, I don't see any pattern there yet. 1, 6, 4, 3, 7. 1 and 6 is 7. 6 and 4 is 10. Yeah, I don't see a pattern here. I'm sure there's a pattern. I just don't see it. 1 and 6, I see 5, I see 2, I see 1, I see 4, I see 7. I don't see the pattern on this one. I multiplied by 6, I subtracted 2, I subtracted 1. Added 5, subtracted 2, subtracted 1. Added 4, added 7, or subtracted 7, subtracted 10, subtracted 13. Um, 7 minus 4. Oh, I think I see it. It's kind of, I think this is, uh, let's, um, 1 plus 6 is 7. 6 plus 4. No, that's not it. Is 10. I saw it and now I lost it. Give me a second. There's a subtraction involved. Add these up, which is 7. 7 minus 4 is 3. Add these two up and subtract this one. 10 minus 3 is 7. Next, add these two up and subtract this one, and you get 0. Add these two up and subtract this one. That's 7 minus 10, you get negative 3. Add these two up and subtract this one. That's 10. And subtract a negative 3. 10 minus a minus is a plus. So you have to add the previous two and subtract the third one. That's what you have to do. Do you see these two add together to get 7? 7 minus 4 equals 3. Okay, now if I add these two up, I get 10. 10 minus 3 equals 7. Then I'm going to add these two up. 3 plus 4 is 7. Minus 7, I get 0, and so on. Do you see? If I add these two up, I get 7, and subtract 13, I get negative 6. Add these two up, and I get 7. I can't. I gotta do it this way here. Let me clear this. So you have to add 2 up and then subtract the third one. So if I add these 2 up, I get 10. 10 minus 6, a minus is a plus, is 14. Give me a second. Okay, so if I add these two up now, 13 and a negative 6, I get 7. 7 minus 14 is a negative 7. So those should be in that spot right there. All right, so that was a tough one. Here I have 0 squares. Here I have 1 square. I have 2 square. I have 3 square. So this one's going to give me 4 squares, 4 corners. But there's more. 1 and then, 0. But then here's 1 filled in. 2 not filled in. 3 filled in. So 4 is not going to be filled in. So I'm not going to color these corners. I'm just going to leave it like it is. Okay, so this next one, if you notice, the inside becomes the outside. The inside becomes the outside. The triangle becomes the outside. Here, the oval becomes the outside. So this one becomes the outside. Bill Troutman. Okay, so I'm back. Let me clear this and draw a better picture. It's a really bad picture. So once again, whatever's on the inside is now the outside shape. This oval is on the outside. So this cross, so I have to do a cross on the inside. That's what it's supposed to be, a cross. Okay, so now we have to figure out what the outside is going to be. And so if you look, this outside, this inside is the outside. So yeah, the inside becomes the outside. This becomes the outside. Whatever's on the inside of this becomes a new outside. Do you see? Whatever's on the inside becomes a new outside. Whatever's on the inside, the triangle becomes a new outside. So whatever's on the inside of this, I don't have anything on the inside, becomes a new outside. So the inside is this shape, the trapezoid. So that goes on the inside, if you could see that a little bit better. So in this, there's this on the outside, the cross, and then there's the trapezoid on the inside. That's what should be right there. You see, the trapezoid is the inside and the cross is the outside. All right. Select a number, multiply by 4, add 8, divide by 2. Let's see what happens here. So they select the number 3. Multiply it by 4. 3 times 4 is 12. Add 8 to it. 12 plus 8 is 20. Divided by 2. 20 divided by 2 is 10. And subtract 4 and I get 6. Let's try this again. Multiply by 4. 6 times 4 is 24. Add 8. 24 plus 8 is 32. Divide by 2. 32 divided by 2 is 16. And subtract 4. 16 minus 4 is 12. Next, 11. Multiply by 4 is 44. Add 8, 52. Divided by 2, 26. 52 divided by 2 is 26. Subtract 4 is 22. Okay, so it says select a number, divide by 2. I'm not exactly sure what else it wants me to do. Is there anything else this thing wants me to do? Oh, I skipped ahead. Apply to given formula, then use the variable n and deduct reasoning to prove the conjure. Oh, we're going to go to the n. So take n and multiply it by 4. I get 4n. Add 8, 4n plus 8. Divided by 2, 4n plus 8 divided by 2, which is really, it reduces. Do you see both of these divide by 2? In other words, 4n divided by 2 is 2n. 8 divided by 2 is 4. So that just reduces to this. And then subtract 4. 2n plus 4 minus 4. If I subtract 4 from this, I just get 2 times n. So let's verify that. So here's my final answer, 2n. If I start with 11 and put 11 into the n, 2 times 11 is 22. You see? 6 times 2, put the 6 into the n. 2 times 6 is 12. Put the 3 into the n. 2 times 3 is 6. And it just says, show that that's all true. Okay. So let's see what's next. I'm not going to do these little book things, but I will go to the next page. So that was 4.1. And once again, that's what the quiz, there's a quiz in Canvas that talks about what's next. And prove or show what the next pattern is. 4.2 estimating. So there's different ways that we estimate. When they just say apply estimation techniques to the following answers. So this problem, if they don't tell you what you're estimating to the hundreds or the thousands or anything, you always estimate to the wholest number. See, 1,175, if you look to the right, it's 4 or less. So this estimates to 1,000. This estimates to the whole number to the left. This estimates to 300. And this estimates to 80. If 9 or more, 5 or more, this goes to 80, and then this is 5. Now you can add them up. 1,000 plus 300 plus 80, 1,385. So if it doesn't tell you, you just round it to the nearest left far digit. If they don't tell you what to round it to the left far digit. Oh, I think in the previous page there was some questions I missed. I forgot to do. Yeah, so let me do this. Let me do this one. I'm going to do this one. 4, add 5, you get 9. Double the result. 9, when I double it times 2, I get 18. Subtract 4. 18 minus 4 is 14. And then subtract the original number, which is 4. 14 minus 4, it's just 10. All right. 9, add 5, which is 14. Double it. 14 divided by 2 is 28. Subtract 4. 28 minus 4 is 24. Subtract the original number 9. 24 minus 9 is 15. 15, add 5, you get 20. Double it, you get 40. Subtract 4, you get 36. And subtract the original 15 from this, I get 21. N, add 5. Double it, 2 times n plus 5. Subtract 4. So you can distribute this, and you get 2n plus 10. Now I'm going to subtract 4, and I get 2n plus 6. 10 minus 4 is 6. 2n plus 6. Subtract the original number, which is n. So 2n plus 6 minus n. 2n minus n is just 1n. N plus 6. Let's see if that worked. Put a 4 in here. 4 plus 6 is 10. Put a 9 in there. 9 plus 6 is 15. Put a 15 in there. 15 plus 6 is 21. Sure enough, n plus 6 is the conjecture. Hi, Colin. Can you hear me? I think you can hear me. I see you don't have a microphone. Where's my chat box? Oh, there it is. I could put it over here. I don't know if that's blocking anything. I think I can put it right over here. I don't know. So can you hear me? Testing 1, 2, 3. Do you see the chat box? Sorry if you can't hear me. I don't know if you, yeah. Okay, good. I see you found the chat box also. I'm not sure because I'm moving around the chat box and all that, how that's going. Unfortunately, I think I'm almost done. I just did 4.1 and I just finished 4.2. Luckily, this is being recorded. Let me move this chat box a little bit. I don't know where to move it to. Let me see if I can just move this over. I think I can move it over. There we go. Unfortunately, I think that made everything smaller. Okay, so that might help me out a little bit. Okay, so I'm still moving on. That was question 1. Now question 2 in 4.2. In the year 2000, the U.S. population was that much. Wow. By good, good, good. I recorded this, so I'll post this later on. The different patterns and all that. That's what the quiz is on this week in Canvas. Also, the different patterns. So it says round each figure to the nearest million and estimate the U.S. population. So I have to round each figure to the nearest million. So if I look at this number here, this is the million spot. So you always look to the next number to the right. 4 or less, you leave that 2 alone. If it was 5 or more, I would add 1 to 2. So this ends up being 282 million. So I'm not going to write the zeros. I'm just going to put million. 282 million rounds to 282 million because the number after it is not 5 or more. Here, this 439 million, if you look at the next 100,000, is 0. So it's just 439 million. Round each figure to the nearest million and estimate the U.S. population. So in the year 2000, this was the population, and it increased. Oh, it increased by 28 million. So here's, if I round that, look to the right, it's a 0. It increased by 28 million for the year. In 10 years, it increased 28 million. By the end of 2010, it increased 28 million. For the year 2050, the U.S. population is projected at 439 million. Round each figure to the nearest million and estimate the U.S. population in 2010. Okay, so we're going to round each figure. In 2000, we had 282 million. But it said by 2010, the population increased by 28 million. So 282 plus 28 is 310 million. So that's our population in 2010. It's a little strange. There's a lot of stuff going on there. It says round each figure to the million and estimate the projected change in U.S. population from 20,000 to 2050. First of all, in 20,000, in 2000, we had 282 million. In 2050, our projected population is 439 million. It says round each figure in millions. We did that. They both rounded to millions. And what is the change in population from here to here? Change means subtracted to 439 minus 282. We want to see how much it changed. 439 minus 282, and it increased by 157 million. So the population increased during that time by 150 million. Perfect, thanks. All right, next problem. Juanita pays $3.10 for a ride on the bus back and forth. So that's a round trip ride to work Monday through Friday. If a monthly pass costs $40, is it cheaper to buy a monthly pass? Well, is it cheaper? First of all, it's $3.10 a day to go there and back. There are 5 days in a week times 5. So 310 times 5 is $15.50. If a monthly pass is $40, well, first of all, how many weeks are in a month? Normally, 4 weeks in a month is 28 days. But not all months have 28 days. Some have more. So let's just multiply this. So this is how much it costs for 1 week of traveling round trip. Now let's do 4 weeks in a month. 1550 times 4 on my calculator. 15.50 times 4, and I get $62. So $62 is what I pay for 4 weeks in a month. But if a monthly bus pass is 40, is it cheaper to buy a monthly bus pass? Oh yeah, it is. If you pay every day, it's $62, and some months have more than the 4 weeks in them also. Sometimes it might be more than 62. So the monthly bus pass is 40, and I would pay 62 each month at least. So yes, it is cheaper to buy the bus pass. All right, so let's take a look at this pie chart. This is the next question. Oh, by the way, Colin, I didn't tell you, but I'm using the workbook. I think I posted a copy of that workbook, the electronic version, I think it was in Module 1. This is the workbook that the face-to-face classes use. When the teacher disseminates the information in class, they all take the notes on the workbook. So the circle graph below shows the percentage of different types of tickets issued by a local police department. So these are tickets issued by, speeding is 35% of all the tickets are speeding. And so on. Running a red light is 21%. So what was the most common ticket issued? The most common ticket is the biggest piece of the pie, right? The biggest piece of the pizza pie. Give me 1 second. I have to hit pause here for a second. Oh, good. You downloaded that workbook. I'm finally seeing what you wrote down. Okay, so here the question is, what was the most common ticket issued? And speeding was, because speeding is the biggest part of the pie, is the most. I don't know why I'm having a circle show up on my graph now. Things are going crazy. So speeding, I can't even write with this now. So speeding is the most common ticket because it's the biggest piece of pie. Let's keep on going. Let's see what's next. If 19,375 tickets were issued, okay, so there's some math involved here. If this many tickets were issued last year, estimate the number of tickets issued for running a red light. Well, if 21% of the tickets were running a red light, then we have to take 21% of this number. 19,375 times 21%. Well, you can't really multiply a percent. Now it also says estimate the number of tickets. And it doesn't say to what place value to estimate it to. If it doesn't say that, you have to estimate it to the far left. So 19,375 estimates to 20,000 tickets. You look to the right, and 5 or more, you add 1 to the underlying number. So we have 20,000 tickets times 21%. You have to change percent to decimal by dividing it by 100. 21 divided by 100 is 0.21. So the answer to this is 20,000 times 0.21. 1, 2, 3 times 0.21. 4,200 tickets are estimated. That's not an exact, that's an estimate of the number of tickets that were running a red light. 21% of the 20,000. Okay, so that was an estimation. If they wanted the exact amount, I would just take 19,375 and multiply it by 0.21. But they asked for an estimate. If 182 tickets were issued for driving under the influence last month, estimate the total number of tickets issued last month. So I don't know why I have this circle around my marker when I'm writing. 182 tickets were issued for driving under the influence last month. Estimate the total number. Well, if let me bring this back up. Under the influence was 19%. So to find that out, I have so many tickets, and I'm going to multiply it by 19%. And the answer is going to be 182. Do you see? We're trying to find out the number of tickets. That's the total number of tickets. If I take the total and multiply it by 19%, the answer is 182. If 182 tickets were issued for driving under influence last month, estimate the total number of tickets issued last month. Well, we have to divide both sides by 19%. Now, if I want to, I'm not sure if they want me to round first or round second. I'm kind of confused on this. I wish they would be more specific on when they want us to round. I'm going to find the exact answer. You've got to get the 19 to the other side solving for x. So 19% is the same thing as 0.19. So I'm going to divide both sides by 0.19, divide this side by 0.19. And you see the percentage cancels, and I'm just left with n equals 182 divided by 0.19. 182 divided by 0.19. And my answer is 957.9. It's actually 89. So, I mean, if I rounded it, it'd be 958. But if I rounded it to the nearest whole number, they don't tell me what to round it to. So I would say about 1,000. If I estimated it, it'd be about 1,000. 957 rounded to the far left is about 1,000. 957 rounds to 1,000. So I'm not sure. They're not telling me what they want to estimate. I would go through the homework and see what they say. Maybe I'll do a couple of homework problems before I leave. I have time. So maybe I'll do a couple of homework problems. Let me see what else we have. We still have a couple more slides. And then I'm going to go to the homework and verify some of this stuff. So I'm on page 51 now. Page 51. It says which month had the lowest number of homes sold. These are the homes sold. Well, you just look for the smallest graph. That looks like the smallest graph, and I would say July of 2013. Which month had the highest number, the highest graph? That's this one right here, October 2013. Approximate how many new homes were sold in June. So if you look June, approximately how many homes were sold? Well, here's 400,000. Here's 450. Right, it looks right between that. So I would say 425. That's an approximation. Right between 400 and 450. Wait, in June? Where's June? Yeah. No, wait. Where's June at? June 2013 is right here. Did I read the question wrong? Approximately how many new homes were sold in June 2013? That's 450. I must have been looking at a different graph. 450,000. That's June right here. I'm putting a square on it. Next. What is the difference in the number of new homes in June and November? The difference between June and November. So once again, June was 450. November Does it tell you anywhere exactly? I would say 460, but it doesn't tell you. Oh, November 2012. Thank you. I'm glad you're here. November 2012 is very specific. It says 400. So June is 450 of 2013. November of 2012 is 400,000. So the difference is you take the largest minus the smallest and you get 50,000. 50, which is 50,000. We're talking about thousands. Okay, so that wasn't too bad. That page wasn't too bad. Let's see if there's any more. Oh, there's always more. So let's take a look at this page. So there's more than I thought on here. Estimate the change in cost per year in attending a four-year public university from 7-8 to 12-13. 7-8 costing attending a four-year public school. The four-year public school is the black graph. See, the private school is the gray. So from 7-8 is right here. 7-8, you have, it looks like 15,000. And 12-13, 12-13 looks about halfway between 15 and 20, which is 17.5. 17.5 minus 15. If I subtract the two, I get 2.5, which is $2,500. I just, this is 15,000. This is 17,500. 2,500 is the 2.5. So I'm estimate the change in cost about 2,500 from 2007-8 to 2012-13. I'm sure there's more. If the cost continues to change at this rate. So this is 2,500. It increased in how many years? Think about it. 1, 2, 3, 4, 5. So it increased 2,500 in 5 years. So we're looking at slope there. And it increased 2,500 in 5 years. The question is, that how much is it per year? So 2,500 in 5 years, divide 2,500 by 5, and that's $500. That's $500 every year. So tuition increases $500 every year. So estimate the cost in 2026. So if at 2012 it's, what do we say 2012 was? 17.5. We want to know what the cost in 26 is. So from 2012, and we want to go to 26. So from 12 to 26 is 14 years. Do you see? From 12 to 26 is 14 years. So, and we know the cost increases 500 every year. 14 years times 500, 14 years times $500 is $7,000 more. So we have 17,000 plus 7,000 more, and we get 24,500. I'm just using the whole numbers in front. I hope that made sense. I mean, it's hard to do the work, and it's so small here to show you that. Good. So I want to go up here. The mathematical model of the cost in years after 2012. So now we got to do the mathematical model. We know the slope is $500 times every year. Do you see? So that, I mean, the mathematical model means write the equation. So we know every year we're going to add $500. So X is the number of years. I guess we could, yeah, X is the years. So 500 times every year. 1 year we add 500. 2 years we add 1,000. 3 years we add 1,500. And we know after 2012, it says after this year, at 2012, we started at 17,500. So this is the mathematical model. Uh, at 2012, it's 17,500. In 2013, starting year, it's 17,500 plus 500. We add a one here. 2 years later is 2014. It's 17,500 plus 500 times two, which is 1,000. So the mathematical model means write the equation. And I'm using the slope intercept form. The equation y equals mx plus b. We started with 17,500 in that year. And each year we're increasing, our slope is 500. We're increasing 500 each year. So 500x plus 1750 is the mathematical model. Let's see if there's anything else. Oh, there's still more, I think. Let's see. Oh, I don't. Did I? Oh, here it is. It says approximate year in Texas population projected to reach 30 million. Approximately what year will Texas reach 30 million? So you just have to go over to 30 million. Here's 30 million here on the line. Go over till we're on Texas. Texas is the red line. 30 million crosses right here. You see, if I come across, it crosses right at that spot. And approximately what year is that if I come straight down? 2020, 2025. So, I'm not sure where these tick marks are. Does this tick mark mean 2020? Yeah. So that's 2020 and 2025. So I'm going to say somewhere around 2022, maybe 2023. Do you see? It's right between these two. So I would I would say it's 2022. It could be 2023, but I think it's 2022. So that's kind of iffy because it could go right down. So let me clear this. If in 2018, 8% of the U.S. population lived in Texas, so we're saying 8% lived in Texas. What was the U.S. population in 2010? So 8% of the population is in Texas. So here's our population. If we multiply it by 8%, we get 25 million. Do you see? Here's 25 million. In Texas, in 2010, we had 25 million people. It said 8%. Here's the total population. The total population times 8% equals the amount in Texas, which is 25 million. So once again, 8% in decimal form is 0.08. N times 0.08 equals 25. The way to solve this for n is, since this is multiplied by 0.08, we're going to divide by 0.08. Divide by 0.08. We're dividing here. Divide. So on your calculator, 25 million divided by 0.08. 25 million divided by 0.08 changes to 312.5 million people total in the U.S. And if you wanted to write that out, 312 million, and then it would be 500,000. There we go. So you had to solve for x for that. Oh, and I think that should be it. There's still more. Wait, there's one more slide. Let me go to this. I wanted to try to do a couple homework problems. I have another meeting at 12, so let's see if we can finish this. Estimate the median income in 2009. Well, here's 2009. 2000, I guess that's 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm assuming that's 9, right? Wait, no, this is 2000. So that doesn't, yeah, so 2001 is here. 2009, if I go straight up, there is a dot there, right there. So the estimation for 2009 is about 55,000. Between what 2 years did the median income decrease the greatest? In other words, where was the sharpest drop? And that looks like the sharpest drop. I mean, we have a drop here, 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 but this looks like the biggest gap. So between what 2 years was the biggest gap? I'd say 2007 and 2008. For what year was the median income below 53,000? 53,000 is here. So the median incomes below that are these two right here, in 2011 and 2012. 2011 and 2012. And that's all I had on that. Now, let me just go to the homework really fast. I don't think I can bring it up on the computer. Let me keep this here and bring this over. If I can do that. Is it letting me? Give me a second. I'm going to bring this over. Okay. And let me go into the homework. I got about 10 minutes. I want to open up the homework really quick. I've been doing some of the homework. Last week, I think I did the homework. So, where is it? Let's look at the homework. So it would be the 4.2 homework. And sure enough, it comes up slow when I really need it. There you go. Okay, estimating. Okay, so I got the homework open now. Let me go to I'm going to go to a blank page. Can I create I don't know if I can. I don't think I can create a blank page here. Are there any blank? Here's another blank pages. Let me take a look around to the nearest given. Okay, that's the given place value. 4.2 around to. See, in the homework, they tell you what obtain an estimate. Then you obtain an estimate for the following computation by rounding the numbers so the result arithmetic can easily be formed by hand or in your head. Then use a calculator to perform the computation. How reasonable is your answer? And it says type in a whole number, so that's pretty easy. I'm trying to go through the homework and see where it matches something from the what we just covered in the workbook. Estimate the total release by rounding the monthly payment. See, it tells you what. See, in the homework, it tells you what to round each one to. Person is 40 hours. Estimate the person's hourly by rounding the annual income to. It tells you what to round it to. I'm still going through the homework. Give me a second. Estimate the number of people per 100 who spell the word correctly. I'm sorry, just give me a second. I should have hit pause on this thing down here.